To multiply monomials together, we need some exponent rules. So really this video is just a bunch of exponent rules. These are really the first, well, you're going to have to memorize these. So this is kind of the first set of formulas that you really do have to memorize for this course. And they never go away. Like, you'll need to know this stuff as long as you're taking a math course. So I'm making you memorize them. But we'll build them up. There's not a ton. So what we want to do is be able to, like, if we have something to a power, multiply it by that same thing to a different power. So remember what powers mean. X to the fourth means x times x times x times x. So if I wanted to do x to the fourth times x cubed, you might think, okay, there's a rule for that. What do I do with the exponents? Do I multiply them? What do I do? Well, let's see. X to the fourth is x times x times x times x. X cubed is x times x times x. Like that. So if you wanted to write that more concisely, which you probably do, you just count the x's. 2, 3, 4, 5, 6, 7. There's 7 x's. So you would think, based off that you actually added the 4 and the 3. And you're correct. So that's it. These aren't complicated rules. You just have to remember what to do. So you add the exponents. All right, so maybe like put a box around these when you're taking notes, because you kind of want to have them all in one place at one point, or I don't know, just memorize them as you go. So if you have x to the m times x to the n, that's x to the m plus n. So you add the exponents. Now, if those are two different bases, then this doesn't work. So it has to be x to the m times x to the n. It can't be like x to the m times y to the n. Those aren't really the same base, so they don't combine. You can still multiply them, but this doesn't happen. Okay, so when same bases, two different exponents, you add the exponents. So for something like that, now you don't have to write out 6 factors of a plus another 1 plus another 4. If you did, you'd basically be doing the same thing, because now you know that you just go 6 plus 1 plus 4. Like that. Okay? So we have a quick rule that says just add them all up. And then remember, this is an exponent of 1. Right? You don't see it there, but this is a to the 1. Okay, now how about this one? The new thing. So now we have an exponent to an exponent. We have x squared cubed. So, you know, maybe you can guess, okay, if in this case we added it, do we do the other thing here? Yeah, it turns out, but let's look at y. So something cubed means times itself a total of 3 times. So that's x squared times x squared times x squared. And by the rule we literally just learned, you go 2 plus 2 plus 2. Like that. So how do you get 6 from 2 and 3? Well, okay, you multiply them. So if that was your intuition was correct. When you have a power to a power, you multiply the powers. Okay, so that's the power rule. So that's, put a box around that one too. That's the second big rule you got to know. If you have x to the m to the n, you do m times n. The exponents multiply. Also known as like the power to a power rule. There's a lot of contexts in math where you have things that are called the product rule and the power rule. So you just have to kind of know what context you're in. Okay, now we have x times y in parentheses cubed. So this is a product to a power. So you see how it's different from the last thing? But it kind of shakes out the same way. So expand that. That's just xy 3 times. And then you could, you know that you could rearrange that into x times x times x times y times y times y, which is the same thing as x cubed times y cubed. So you have 3 total factors of x, 3 total factors of y. So what you'll see is it looks like the power kind of distributed to both of the factors in the product. And yes, that is what happens. So there you go. There is your that's called the product to a power rule. I have a product rule and a power rule. Now I have a product to a power rule. So I have xy to the n equals x to the n times y to the n. So you can kind of think about that as distributing. The power distributes to every single factor in the product. And if there was more of them, if it was x, y, z to the n, you get the idea that, okay, then the power would just hit the z as well, because why wouldn't it? Okay, let's just do one kind of nasty example. It's not really that bad. You just use the couple rules we just busted out and then group stuff together. So I would say the first thing to do here is take that second term, negative 2ab cubed squared, and actually apply the product to a power rule. And the product to a power rule says you just square everything in there. So we didn't touch the first term, the negative 4a7b, but we're going to square the negative 2, we're going to square the a, we're going to square the b cubed. So remember, negative 2 squared is positive 4. A negative number to an even power is always going to be positive. So that's negative 2 times negative 2, which is 4. A squared is just a squared. B cubed squared, what do you do with those exponents? You multiply them. 3 times 2 is 6, so that's b to the 6th. And now the parentheses aren't really doing anything, so you're going to combine like terms, and before you do that, you can write them next to each other. Or you can skip that and do what I did. So negative 4 times 4 is negative 16. A to the 7th times a squared is a to the 9th, so I added those exponents. And then b times b to the 6th is b to the 7th, because there's an exponent of 1 that you don't see on this b. Or just think about it, if you have b to the 6th and multiply by one more factor of b, well, that's exactly what b to the 7th is. Okay, so really, again, it's just all about combining like terms. You're multiplying like terms. We just have these 3 new rules we can use. So this section is a lot of just, here's a big nasty algebraic expression, simplify. And it gets a lot worse than this, frankly. So you just really have to have it to where you can bust out these rules very quickly, because like I said, they'll never go away and you're always going to have them memorized. Okay, so that's just 3 rules. We're going to have some more in the next section. Thank you.